In this math lesson, we're going to go over each piece of information given on the reference table.
Alright, so let's look at these first 5 that I kept here. These 5, I think you should definitely have memorized before taking the test. It's going to be a waste of time to go back and look at these, and these are common formulas that you have used throughout your time in school. So area of a circle is pi times the radius squared. Something that's not shown here is diameter, which goes all the way across, and we have a relationship that the radius is half the diameter. So the radius is used in finding the area or the circumference. Area, what's inside the circle, is pi r squared. Circumference, the length around the outside of the circle, is 2 pi r. For a rectangle, we have area is simply length times width, and if we had a square, the length and width are the same, we'd call them sides. Area is side squared. Area of a triangle is 1/2 base times height. So here we have a base, we have the height drawn down. So I want to point out, if we had a right triangle, and this is the base, this side here would be the height. If we had a triangle like this, and this is the base, the height would actually come down here to where it made a right angle with the base. Here we have Pythagorean theorem. Typically we write it as a squared plus b squared equals c squared. But obviously this is the same, c squared equals a squared plus b squared. Then we have volume of a prism, which is just the length times the width times the height. Okay, let's look at these special right triangles, 30, 60, 90, and 45, 45, 90. So for these, we're actually given relationships between or among the sides of the triangles. So let's look at 30, 60, 90. If we know what x is, we'll know all the sides. So for example, if this side is 5, then this side, which is 2x, would just be 2 times 5, 10. This side, which is x radical 3, would just be 5 times radical 3. If we were given this side to be 20, that matches up with 2x, making x equal to 10. So therefore this side would be 10, and this side would be 10 radical 3. More difficult is when we're given this side. So let's say this side is 12. So the 12 matches up with x radical 3. So to find out what x is a little bit more difficult. We'd have to just set it equal to x rad 3 and then solve. Divide by radical 3, divide by radical 3. So we have to reduce this. If we have 12 over radical 3, what we want to do is get rid of the radical in the denominator. So multiply the top and bottom, numerator and denominator, by radical 3. So on top we get 12 radical 3. Then here radical 3 times radical 3 is radical 9, which is 3. This reduces. 12 divided by 3 is 4, so we have 4 rad 3. So now we know x is 4 rad 3, so that means this side is 4 rad 3. This side is twice that, which would be 8 rad 3. And the same method we used to find these sides, we could use in a 45, 45, 90 triangle. This one's a little bit easier because these two sides are the same. So, for example, if this is 10, this would be 10, and this is 10 rad 2. If this side is 10, we'd have to set it equal to s rad 2, and then we'd have to solve for s by dividing by rad 2. So we could do that. I'm going to do it over here. Just simplify. Multiply numerator and denominator by rad 2. So we get 10 rad 2 on top. Rad 2 times rad 2 is radical 4. And the square root of 4 is 2. Then this reduces. 10 divided by 2 is 5. 5 radical 2. So each of these sides would be 5 radical 2. So maybe it's not important to memorize these. I think if you can, you should. But definitely keep in mind while taking a test, if you see a triangle with a 30, 60, or 45s, to look here and identify the relationships. These three formulas here all have to do with volume. So we have volume of a sphere, such as a ball, volume of a cone, and volume of a pyramid. So make sure that when you actually use these formulas, you don't mix up this fraction here. This is 4/3, 1/3, and 1/3. Then also important for these questions is that you use the height. This measurement here is not the height. This is the height. So in order to get the height in this case, we can look at this and see that this is a right triangle. So if we have, for example, that this is 5 and this is, let's say 20, we could find the height by using Pythagorean theorem. And then we just have some math and we could find the height. And then same thing here. This is a little bit more difficult because this would be the base of the triangle, which is half of this diagonal here. But all the formulas are given. We have the diagrams. Make sure you do not mess up the fractions, and also don't mix up the exponents. It's probably not worth it to actually memorize these. They don't show up very often. It is likely that one of them may show up, but it's more important just to know that they do exist and that they are given to you. Alright, also we have these three facts here that are given. These more or less go together. The number of degrees of arc in a circle is 360 degrees. The number of radians of arc in a circle is 2 pi. So what that's saying is all the way around the circle is 360 degrees, and all the way around the circle is 2 pi radians. So we have a relationship here that 360 degrees equals 2 pi radians. So now we have a way of converting between degrees to radians. So degrees over radians is 360 over 2 pi. And we could use this to find radians if we have degrees, or degrees if we have radians. The other fact has to do with the triangle, that the sum of the measures in degrees of the angles of a triangle is 180. So A degrees, B degrees, C degrees, these all have to add up to 180 degrees. Now, it's not given, but it's also worth noting that there's a relationship between the number of sides and the sum of the angles. So a triangle with 3 sides has 180 degrees. Quadrilateral, 4 sides, would be 360. A pentagon, a 5-sided figure, is 540. A 6-sided figure is 720. Now, I don't have these memorized, but what I do know is that every time you add a side, you have to add 180 degrees. Just keep on adding 180, and then you can make this table for yourself. And this is not given. You do have to memorize this. In fact, even though these are given, these are definitely worth memorizing before taking the SAT.